equations. So absolute value equations. Again, this is very similar to the regular solving of equations, only with that one difference that I told you. And that one difference of having those two different equations is, I don't know how to explain it. So when you have the two different solutions, basically you're having, the reason for that is called a disjunction. So a disjunction is a mathematical statement created by connecting two other statements. With the word or. So a disjunction is kind of what I was explaining the other day when we talked about the piecewise, right? So you have two different functions, so your options are, it's either going to satisfy this equation or it's going to satisfy this other one. That's the disjunction. But if you remember, I kind of mentioned the reason the absolute value graph looks complete and together and connected and everything is because where the whole should be, that other function fills it in, it replaces it. So that's why you get that filled in and it looks like one perfect little graph. Okay. So we've kind of already done this. I should have done this in a separate color. This is the title. Okay. So we're just going to do an example, but that's why you get two equations, because of that disjunction. So example 2, absolute value of x minus 5 minus 4 equals 2. So I'm going to do like what I usually do. I'm going to move my 4 first, leaving that 2, absolute value of x minus 5 equals 6. Okay, now I want to get rid of that 2. So I divide this all by 2. Giving me that x minus 5. 6 divided by 2 is just 3. Okay. And then I get my two different equations. My x minus 5 equals 3, and my negative x minus 5 equals 3. Okay, so this first one, easy enough. I just add 5 to both sides. And that's going to give me x equals 5 plus 3 is 8. So that's my first point. And then I have to, remember, take all my signs and basically flip them. So positive and a negative gives me a negative. Negative and a negative gives me a positive. Then I can just write my x and my 5 equals 3. Okay. Remember, the negative only affects what's in the parentheses. So now I'm going to move that 5 over by subtracting it, which gives me a negative x equals 3 minus 5 is going to give me what?
-2.
-2. Now, I can never have a negative x value. So what I have to do is multiply by 1 or -1. And that's going to give me x equals a positive 2. So those are my two solutions for this problem. Okay. Meaning it's going to be x equals 8 or x equals 2. Oh my gosh, I got scared because I'm looking at your book and I scrolled down and they're like, okay, so do this. And I'm thinking they're using the same equation and then they don't get those answers. But it's okay because they did a different equation. So it's fine. We're all good still. So there can also be an absolute value with fewer than two statements. So that would mean either 1 or 0, right? So basically that happens when I'm trying to figure out how I can do this without just having a new example at the bottom. So, okay, well, I can do this one so you guys can see. So there's two, I've got it. Okay. Situations. I feel like I'm spelling that totally wrong, but you guys know what I mean. Situations with less than two solutions. Okay, so when that happens, the first case is your absolute value equals a negative number. Or number 2, it equals zero. Okay, so for the first case, we have negative 5 x plus 1 plus 2 equals 12. So again, I do my same routine. I subtract 2 to both sides. Equals 12 minus 2 is just going to give me 10. Now, if I divide by both sides by negative 5, I'm going to end up with the absolute value of x plus 1 equals 10 divided by negative 5 gives me what?
Negative 2.
Negative 2. Absolute values can never be negative, so it's impossible that that would ever happen, right? So therefore, this one will have no solutions. Okay. And I'll go back to that page. I just want to do the second example. If you guys need to see the rest of those notes. So the second one, and if yours can all stay on the same page, it's much better, but I think I wrote it too big or too much spacing. I'm not 100% sure. But something definitely went wrong that mine is on 2 different pages. But so we have the second example, which is 3/5 2x minus 4 minus 3 equals negative 3. So my first step is add 3 to both sides. That leaves me with a 3/5 2x minus 4, which equals 0. Now, I need to get rid of this fraction, so I multiply by what? What is it called? Begins with an R.
The reciprocal.
The reciprocal to both sides. So we're going to cancel. equals to 0. Okay, so book says that when I do this, 0 and negative 2x minus 4 equals 0. I add 4 to both sides. I'm going to go ahead, 2x, that cancels, equals plus 4, divide by 2 to both sides, and x gives me x is equal to 2. Okay, now when I do the other side, negative 2x plus 4 equals 0. Okay, I'm going to subtract 4. That gives me negative 2x equals negative 4. When I divide both sides by a negative 2, what does that leave me with?
2.
2. So this is how it's really one solution, because both of these are the same number. You don't have to write x equals 2 and x equals 2. You would just write it once. So that's why it's considered just one solution. Okay, does that make sense?
Well,
Yes.
wait. So
What?
there can be 2 solutions or one solution?
There can be 2 solutions, 1 solution, or no solution. So our first example that we did had 2 different solutions, right?
Right.
X equals 8 and x equals 2. This one here has no solutions, and I didn't even have to keep going, because once it
How do
equals
you
that,
know?
it has an equal to a negative 2. Remember the absolute
So
value
if it's
can,
equals negative, it's not?
it's no solutions, because you can't have a
Okay.
negative. So like if I continued and did, let's say just for an example, you guys don't have to copy this, but just so you can see, let's say I did this one and I decided I'm going to work through it anyway. X plus 1 equals negative 2. Negative x plus 1 equals negative 2. Okay, so when I do that, that gives me a minus 1, minus 1. So x equals negative 3. Can't be negative. And this one, negative x minus 1 equals negative 2. This is going to be, this actually ends up being a positive, but you don't even have to go that. Once you get to this step and it has that negative 2 value, it's not going to work. It's never going to meet that point. Your graph isn't going to hit that. Okay, so once you see that there's no that it equals negative 2, you don't even have to continue. Once you get that absolute value by itself to equal a negative number, you stop. No solutions. Okay, and then our last situation, we had technically we had 2 solutions, but they both equaled the same thing. So it doesn't matter what I write. I can just leave it as x equals 2. Okay. Does that make sense? Yes, maybe. Okay. So moving on. That's actually the end of the section. So it was pretty short today.